So I want to talk about another method for conducting a hypothesis test for the mean. This is called the p-value method. So if our sampling distribution is bell-shaped, and we want to conduct, let's say, a right-tailed test this time. Remember that if I'm using the critical value method, then I draw a line and I find t critical, and where I position that line is based on alpha. In this method, instead of comparing a t-test to t-critical, I'm actually going to compare two probabilities, what we call the p-value, and I'll compare that to this level of significance alpha. So when I find my test statistic, so in other words t-test, and remember that's found by taking your sample mean and looking at the difference between that and the assumed mean relative to the standard error of the mean. So I'm still going to have to find the test statistic, and I'll see where that test statistic lies. If it's once I find that test statistic, I'm going to find the probability. If it's a right-tailed test, I'm going to find the area that's to the right of that. And to do that, you would need to use your t CDF function. And so remember, the way this works is you have a lower bound, an upper bound, and degrees of freedom. And so that would tell me the p-value is the likelihood that I would get a result as extreme as the one that I did in my sample, assuming that the null hypothesis is true. So, but I also want to point out that this is something else that is calculated automatically in your TI-84 when you use the t-test function. It's the value here where it says p equals. In this case, I was getting a result of 1.05 times e to the negative fifth. So that's actually, when I have that e to the negative 5 there, it means I really would need to move this decimal place 5 places to the left. And so this is a very small probability. So when the p-value is really small, that says that the likelihood of that result, assuming that the null hypothesis is true, is very small. And so when the p-value is less than your level of significance, then you reject the null hypothesis. Now, if we were conducting a left-tailed test, then of course, if you want to kind of picture how that would work, my alpha is over here, so that's the where I'm saying that if a result has a probability that's less than 5%, then I'm going to reject the null hypothesis. So, for instance, if I get a probability that's so that the area to the left of my t-test value, if that area is less than 5%, I'm going to reject. Now, notice that the two strategies for testing, whether you're using the critical value method or the p-value method, you're going to get the same result as far as whether you'll reject or fail to reject. Notice that this line, if I'm using the critical value method, the t-critical, that where I position that, the way I find that, is based on alpha. So those two things are tied together. And the p-value is tied to this test value. So I can either compare t-critical to t-test, or I can compare the p-value to alpha. Either strategy is fine.